Hello students, today we are going to discuss correlation. This topic is very important in your current semester. Today we are discussing few topics like objectives, introduction, definition of correlation, scatter diagram, Correl-Pearson coefficient of correlation, example problems, correlation coefficient for a bivariate frequency distribution. So, we will discuss one by one. So, actually what is the objectives of studying this course? After studying this unit, the student should able to know the importance of correlation, derive the correlation coefficient formula, know the properties of correlation coefficient, calculate the correlation coefficient, compute correlation coefficient for a bivariate frequency distributions. That means, we are after studying this unit, you should understand the concept and you will apply what are the things we are discussed today. Introduction to the correlation. So far we have conformed ourselves to univariate distribution, that is the distribution involving only one variable. We may however come across certain series where each term of the series may assume the values of two or more variables. For example, if you take a Poisson distribution, only one variable is involving, that is lambda. Lambda is a parameter. So, that probability mass function of the Poisson distribution is probability of x is equal to small x e to the power of lambda x, lambda power x by x factor. How many variables involving in this distribution? Only one variable, that is why it is known as a univariate distribution. Coming to our topic, for example, if you measure the height and weights of a certain group of persons, we shall get what is known as bivariate distribution. That means, one variable relating to height and another variable relating to weight. Definition of correlation. In a bivariate distribution, we may interested to find out if there is any correlation or covariation between the two variables under study. Is the change in one variable affects a change in the other variable? The variables are said to be correlated. Correlation is a statistical analysis which measures and analyzes the degree or extent to which two variables fluctuate with reference to each other. For example, correlation means student and teacher correlations, that means attending the classes, gaining of the marks, there is a relation. So, this type of relations we will explain in upcoming slides. If the two variables are deviate in the same direction, that is if one variable is increasing or decreasing in one results in a corresponding to increasing or decrease in the other. In that case, correlation is said to be direct or positive correlation, but if they constant deviate in the opposite directions, that is if increase or decrease in one result in corresponding to decrease or increase in other, correlation is said to be diverse of negative. For example, the correlation between the heights and weights of a group of a persons, the income and expenditure is positive, and the correlation between the price and demand of a commodity and the volume and pressure of a perfect gas is the negative correlation examples. First one is positive correlation example. So, positive correlation examples are height and weights. If height is increasing, weight is automatically increasing. That means, it indicates that there is a correlation between the height and weight. Similarly, income and expenditure. If our income is increasing, expenditure is also increasing, that both will be goes positive direction. These are the two examples for positive correlation. While coming to negative correlation is price and demand of a commodity and volume and pressure of a perfect gas. These are two examples of the positive and negative correlation. Now, one more relation we have, that is either positive or negative, one more correlation is that is perfect. When we say the given correlation is perfect, correlation is said to be perfect if the deviation in one variable is followed by the corresponding and proportionally devious in the other. This type of relation is said to be perfect correlation. So, methods to study correlations. We have different methods in to find out the correlation between the two variables. The intensity of correlation between two variables can be measured by the following methods. First method is scatter diagram or dot diagram method. Coming to second one is Karl Pearson coefficient of correlation. Third method is correlation coefficient for a bivariate frequency distribution, and fourth one is rank correlations. These four methods are to identify the correlation coefficient between the given data set. Now, first one we will discuss one by one. First one is what, apart from that methods, first one is scatter diagram method. What do you mean by scatter diagram actually? It is the simplest way of the diagrammatic representation of bivariate data. Thus, for the bivariate distribution in terms of xi comma yi, I takes the values 1 to n. If the values of the variable x and y be plotted along the x axis and y axis respectively in the xy plane, the diagram of dots so obtained is known as scatter diagram. So, if I take the x variable values and y variable values are plotted on the xy plane, then we will get one diagram. That diagram is known as a scatter diagram. From the scatter diagram, we can form a fairly good though vague idea whether the variables are correlated or not. So, by observation we can find this. Example, for example, if the points are very dense, that means very close each other, we should expect a fairly good amount of correlation between the variables, and if the points are widely scattered, that indicates that a poor correlation is expected. That means clustered somewhere, the dots are clustered somewhere in that xy plane. However, this method is not suitable if the number of observations are fairly large. In that case, that means more number of observations are given to us. In that case, identify and plotting of the dots will not get that more. It is very difficult to identify all the observations on the plotting of the scatter point. In that case, that is difficult. In that case, we can go for another method. So, another method is Karl Pearson coefficient of correlation. This is the best method to identify the relation between the correlation between the two variables. As a measure of intensity or degree of linear relationship between two variables, that is, this method was introduced by Karl Pearson in the year 1867 to 1936. A British biometrician developed a formula called correlation coefficient. Using this correlation coefficient, we should identify what is the relation between the given data set in terms of x variable, in terms of y variable. Correlation coefficient between two random variables x and y, usually denoted by r of x comma y. Simply, r of suffix of x comma y is a numerical measure of linear relationship between them and is defined as correlation is represented by what? R of x comma y. Therefore, r of x comma y is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. If x comma y, that means xi comma yi, I takes the values 1, 2, 3 and so on n, is the bivariate distribution, that means pair of number of observations. Then covariance of x comma y, what is the covariance of x comma y formula in terms of mathematical expectation? We can write covariance of x comma y is equal to expectation of x minus expectation of x of y minus expectation of y. That we can write in terms of numerical point of view. We can write summing over 1 by n, summing over summation xi minus x bar, where x bar is what? Mean, yi minus y bar, that is covariance value. So, now we can evaluate the values, we can derive the values using the formula covariance of x comma y is equal to what? 1 by n into summing over xi minus x bar into yi minus y bar. This is the formula for covariance. Now, we can get the standard deviation of. So, standard deviation means So, we can apply the standard deviation formula in terms of mathematical expression, that is sigma x square, it is known as a variance. If I take the sigma x, then it is known as a standard deviation. If it is sigma square, it is a variance. So, sigma square x is equal to expectation of x minus x whole square, that we can write in terms of 1 by n into summing over xi minus x bar whole square. Similarly, we can define sigma y square. Sigma y square is equal to expectation of y minus expectation of y whole square, that we can write in terms of mathematical formula 1 by n into summing over yi minus y bar whole square. These two are parameters. We know the covariance of x comma y values, we know the standard deviation of x, and we know the standard deviation of y. These three values we can substitute in correlation formula, then we will get correlation coefficient. That means covariance of x is equal to this, we can write covariance of x comma y, another formula this is. Finally, we can write r of x comma y is equal to 1 by n into summing over, this we can use it for step deviation point of view sometimes. So, r of x comma y is equal to, r of x comma y means what? Correlation. Correlation of x comma y is equal to 1 by n into summation xi minus x bar yi minus y bar divided by under root of 1 by n into summing over xi minus x bar whole square into 1 by n into summation yi minus y bar whole square. Therefore, this is also we can write in simplified form. Here 1 by root over 1 by n into 1 by root n, we can taking outside this numerator root 1 by n into root 1 by n, then we can get only 1 by n, numerator 1 by n and denominator 1 by n will be cancelled here. Then we will get the new formula, that is r of x comma y is equal to summing over xi minus x bar into yi minus y bar divided by under root of summing over xi minus x bar whole square into summing over yi minus y bar whole square. Where, so here the summation, we have all the, this is the formula, we have to get the two formulas here, first one is another formula, this is a, now we are discussing few formulas. Before that, where the directive fractional, two types of problems are available, especially in correlation. If your data set is, given data set is in all are integer forms, sometimes the fraction, that is mean value is integer form, then you can use the direct formula. Sometimes x bar and y bars are will get fractional forms, in that case direct formula is little bit of time taken process. Okay, in that case time consumption process, in that case we can go for deviation process. Okay, here if first case is if x bar and y bar are fractionals and x and y assume large values, above formula are not generally used for numerical problems. In such a case, the step deviation method can be used. What is the step deviation method actually? So, Carl Pearson correlation is given one between the relation between the x and y is given to us, that is r of x comma y is equal to n into summing over dx into dy. You see this in this slide, r of x comma y is equal to n into summing over dx into dy minus summation dx into summation dy divided by under root of n into summation dx square minus summation dx whole square into n into summation dy square minus summation dy whole square, where what is d? D stands for what is n here? N is equal to number of pair of observations. What is d? D of x, here where of d of x term is available and d of y term is available. Actually, what is d? Dx, dx is equal to x minus a, where a is any arbitrary value, and similarly we can take dy value, dy is equal to y minus yb. See here already I said, that is what are the parameters, unknown quantities here a and b. So, here a and b are any arbitrary values in x and y series respectively. For example, we will discuss one or two example problems in this case, how to calculate the correlation coefficient. Okay. So, in that first example is calculate the correlation coefficient for the following heights in inches and of fathers. Fathers is represented by x and their sons, their sons is represented by y variables. Here x series follows what? X represents heights in fathers, okay, 65 inches 66, 67, 67, 68, 69, 70, 72. This series is represented for father's height. Then y series is represented for son's height. What is the son's height here? 67, 68, 65, 68, 72, 72, 69, 71. Now, how much correlation between these two we need to identify? How to calculate the correlation based on known formulas? Okay. So, solution for this above problem is, now we can solve this problem by making use of Carl-Pearson coefficient of correlation formula. We can use it for getting of correlation of the above data set. So, for that Carl-Pearson correlation coefficient is also called product moment. Product moment, another name of the Carl-Pearson coefficient correlation is what? Product moment is given by R of x comma y is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. Already we know covariance of x comma y we can write in terms of our summation of x y divided by summation of under root of summation x square into summation y square. Now, how to calculate these things? I can use one table format, or simply I can explain for this how to calculate the correlation between x and y. See this table. So, what I said earlier, x represents what? Father height, y represents what? Son's height. Now, so first column total we can take. What is the total of this first column? If you can adding all the summation values 65 and 66, 67 and up to 72, you can adding this. This is known as a summation of x, summing over x values. If you summing over these x values, we will get what is the values here? 544. Now, similarly, we can calculate the y values. Y is the son's heights. So, the total is what? 544 here both. Okay. Now, then immediately you can go for x square, squaring of these two terms, squaring of x square, squaring of y square. Then you can product of x into y, because in your formula summation of x y is required, summation x square is required, summation y square is required. Third column is given the data set value, total summation values, that is summation x square value. This is the summation x square value. Now, fourth column is given to us summation y square value. So, what is the summation y square value? 38,132. Now, if I take the product of the x and y, that is why this is known as a product moment relation. Product moment relation, that means summing over x and y. You can adding this. This is the total summation x y total is equal to 37,560. Okay, now above values. Now, using the above values, we will substitute these values in above formula, we will get a relation among these variables. That variable values are what here? From the above table, we will get summation x and summation y values, summation x square value, summation y square value is how much? 38,132, summation x y is equal to 37,560. So, now these values we can substitute in your formula. So, that is what is the formula? R of x comma y is equal to summation x y. What is the summation x y value? 37,560 we can write, divided by under root of summing over x square value. What is the summation x square value? 37,028. What is the summation y square value? 38,132. So, now we can simplify this. After simplifying this, these values we will get 0.603. So, what is the relation? This is R value. This is known as a correlation coefficient value. Based on this correlation coefficient value, we have to make the conclusion. So, how much relation between these two variables? The correlation coefficient R is equal to 0.603 shows a positive correlation between heights in inches of fathers and their sons. So, according to given data set, the relation among the two variables what in terms of father height and his son's height also follows positive relation. Okay. This is one example for positive correlation. So, one more example we are taking for computing the correlation coefficient of the following data sets. So, in this example, x series and y series value, x values are for 1, 3, 5, 7, 8, 10, while taking the y series values are 8, 12, 15, 17, 18, 20. So, The Carl-Pearson correlation coefficient between x and y is denoted by R, already you know, is defined as R is equal to n into summation xy minus summation x into summation y divided by under root of n into summation x square minus summation x whole square into under root of n into summation y square minus summation y square. So, this is formula. Now, we need to calculate above mentioned values by making use of table format. We need to calculation. How to calculate this? Now, we can x values and y values, x y is product values are required for us, x square value is required and y square value is also required to get the correlation coefficient between x and y. So, now we can adding the total summation of x, summing over 1 plus 3 plus 5 plus 7 plus 8 plus 10. How much it is? That is known as a summation x. The total is how much here? 34. If I adding y series values, what is the y series values here? 8, 12, 15, 17, 18, 20. So, if I adding this all these values I got, that is the total values of y series, that is known as a summation y is equal to 90. Now, I can product of multiply these two variables 1 into 8, 8, product of these two variables x into y, 1 into 8, 8, 3 into 12, 36, like 5 into 15, 75, 7 into 17, 119, 8 into 18, 144, 10 into 20, 200. Then I got which values here? X, y values. If I adding these all these values, I got total values, product of the x and y values, that is summation x y is equal to 582. Now, similarly, I can square this time because I would like to find out the summation x square value now according to our formula. Summation y square is also required for us. For that, what I am doing here, I can take the squaring of all the individuals of x series. For that, x 1 square 1, 3 square is 9, 5 square is 25 and so on, 10 square is 100. Therefore, summation x square is equal to 248. Similarly, I can get the last column total. What is the last column total? It is a y series representation. I can get the y summation y square value, squaring of all these values. What is the 8 square? Then I get 64, 12 square 144. Using calculator, you can use and adding all the y square terms. If I adding y square terms, then I got summation y square value. What is the summation y square value? 10446 is the total. From the above table we got which values here? Summation xy we got, summation x square values we got, summation y square values we got. These values you can substitute in your appropriate formula. So, from the above values you can substitute in the known formula. What is n value here? Number of observations are 6. Okay, R values you can from the above table we get these values. All these values you can substitute in your correlation formula. What is the correlation formula? Already you know. So, R is equal to R of x comma y is equal to 6 into 582 minus 34 into 90 divided by under root of 6 into 248 minus 34 whole square into under root of 6 into 146 minus 90 whole square. If I simplify this, I got R value. What is R correlation coefficient value? R is equal to 0.987. This is almost positive, highly positive related, highly positive correlation because it is almost identical equal to 1. Okay. The relation between the above mentioned data set is, it's we conclude that this is the positive correlation between the given data set, which shows highly positive correlation between the x and y variable. So, one more data here, data is given, sometimes rank values is given, sometimes summation values are given. We need to find number of observations also by making use of the known concepts. So, I explained one example problem. In that case, our problems just I will go for this problem, that our problem data set is given to us. In that data set, using making use of this data set, apply the known formula and we will get what are the data is there asking. So, now I am going to explain one example problem here. From the data given below, R is equal to 0.5. What is R? R is equal to rank is given to us. Summation xy is equal to product of xy value is given to us 120, standard deviation of y is given 8, summation x square value is given, where x and y are deviations from arithmetic mean. Find the number of items n, that means we need to find n value. Here already given in your question, what is the given here? Here x and y are for deviation from the arithmetic mean, that it means what? X minus x bar, x is equal to x minus x bar, y is equal to y minus y bar. Now summation xy is equal to what? Summing over this xy we can write what? Deviation, small xy we can write x minus x bar, in place of y is equal to we can write y minus y bar. That value is equal to already given. What is the value? Summation x minus x bar into y minus y bar is equal to 90. Now standard deviation of y is already given. What is the standard deviation of y formula? Under root of 1 by n into y minus y bar whole square. That value is already given to us. What is the value? 8. Squaring on both sides, the root will be cancelled, that is 8 square means what? How much here? 64. So summation xy square is equal to, here 1 by n is divided, then is n is coming to this side, it becomes multiplied. That becomes 64 into n. Which value it is? Summing over y minus y bar whole square is equal to 64 into n. So what is actual formula of correlation? Correlation of r comma x comma y is equal to r of x comma y is equal to covariance of x comma y divided by standard deviation of x. You know this formula. I can substitute all these values, then I get what is the n value. I know what is the product value of this. Already we got 90. So n into this means what is the value here? 120. So 120 already is given, 120 divided by under root of this value. So now we can simplify this. After simplifying this expression, we will get n value is equal to 10. So another problem, so because sometimes we have to take this deviations. So for the deviation problem example also we will discuss one. We will discuss one example problem which is related to deviation related concept. Okay. Sometimes it is not possible to, our observations are very large, our data, given data set is already we discussed when we apply the deviation methods. So find the correlation coefficient between the heights and weights of the following data. Heights in inches and weights in lbs. Okay. So is there any relation between the height of the person and weight of the person? Then we need to find according to the given data set. So 57, 59, that means its x series and its weight is represented by y series. 57, 59, 62 and so on. Last observation is 57. Coming to weights, 113, 117, 126, 126, 130, 129, 111, 116, 112. Okay. So now I can apply the, which method is we can apply appropriate one. So already you know Corley-Pearson coefficient method here. So before that I can find out the, what is the x bar value, how to get the mean value. So summing over 1 by n is summation x y bar. Number of n is equal to number of pairs of observation. How many number of pairs of observations available in your question? 9 observations. Now I can go for the table format. Okay. So now finally using this table format, then we will get these values. Making use of these values, I got the relation. What is the relation here? 0.98. From making use of that table, I can substitute all the calculated value in the known formula. I got 0.98 value. It indicates that what is the relation between the height and weights. So there is a positive relation between the height and weight of the person. Okay. Finally, I conclude what is the summary of the unit. In this unit, we have already discussed introduction of the bivariate distribution, scatter diagram, definition of correlation, Corley-Pearson coefficient of correlation and example problems and properties of correlation coefficients. These are the today's topics. Okay. I hope you are understanding this concept. So because this is we can use the in our daily life. If you are understanding this concept, we can answer to many questions, we can answer to whatever the questions asked in examinations. By making use of appropriate methods, you can apply it and you will get good outputs. So this is the summary of the correlation concept.